Welcome back to the channel. In my previous video I showed you how to build a full POS system using just Google Sheets and appscript. But honestly, that video was a bit rushed and I feel like a lot of important details were skipped over. So today I want to take my time and walk you through the entire process properly, step by step. By the end of this video you will be able to build this fully functional POS system yourself from scratch. Let me get started by showing you the final result first so you know exactly what we are working towards and what the finished product looks like when it is all done. If you have been looking for an affordable way to manage your business, you probably already know that commercial POS software can be quite expensive. Some systems cost hundreds of dollars per month just for basic subscriptions. You end up paying for licensing fees, hosting charges, and monthly subscription costs. And if you need any customization at all, the development costs can feel incredibly intimidating, especially if you are not a programmer yourself. But here is the good news. You do not need to spend all that money. In this tutorial I am going to show you how to create something that works just as well as those expensive systems, but it is completely free to run. Even if you have never written a single line of code before, if you stay with me through this whole video you will be able to build this system for your own business. You can even use AI tools like ChatGPT to help you generate the code. You will find it is actually very simple once you understand the right approach and the correct way to structure everything from the start. So do not worry if you are a complete beginner, I will guide you through every single step of the process. We are going to build this step by step and I want to make sure everything is well organized so you do not get confused or feel like giving up halfway through. The key to success with any project like this is to have a clean and organized system right from the beginning. So before we start building anything, let me first show you something I have already built. This way you can see exactly what we are working towards and understand the end goal before we get into the technical implementation details of how everything works behind the scenes. So as you can see right here on the screen, this is the POS system that I have built. Right now I am inside Google Sheets, and if you look at the top of the browser you can see it is running on sheets.google.com, which is completely free to use. This spreadsheet acts as our database storing all the information for our application. If you look at the bottom of the screen you will notice several sheet tabs listed here in a row. We have tabs for communication logs, debts, M-Pesa transactions, products, categories, and more. Each sheet tab stores a different type of data for our system. There is a sheet for all your products with their prices and stock levels, a sheet for recording transactions, a sheet for tracking debts and payments, and even a sheet for user accounts and permissions. The beauty of this approach is that because everything is stored in a spreadsheet, you can easily edit any data directly if you need to make changes or fix something. If you need to update a product price or correct a customer record, you just come here to the sheet and edit the cell directly. It is really that straightforward. So this spreadsheet behaves as our database storing all the information for our POS application in a clean and organized way. Right here I am clicking on extensions at the top of Google Sheets and selecting appscript from the drop-down. This opens the appscript editor where you can see the editor interface with a file panel on the left and the code editor in the center. At the top there is a toolbar with buttons for running, debugging, testing, and deploying your application. This toolbar gives us access to the deploy button. So from the toolbar I click on the deploy button here at the top right corner. A drop-down appears with options including new deployment and manage deployments. The options are listed there for you to choose from. Now at this point I click on manage deployments from the drop-down. This opens a window showing all the versions I have deployed in the past with their timestamps. From there I click on the web app link and it takes me directly to the live application, which opens in a new browser tab. When the application loads I see the login screen where I can sign in with my credentials. I type in the username and password and click login to access the main dashboard. Here on the login screen I am typing in the username and password. For this demo it is simply admin for both the username and the password fields. Then I click on the login button and the system authenticates and loads the main interface. Now you can see the full application layout. On the left side there is a sidebar with all the navigation options. You have point of sale, products, categories, users, and more options listed there in a neat menu. On the main panel we have the dashboard, which gives you an overview of your business at a glance. You can see cards showing key metrics like total sales, total products, total profits, low stock items that need attention, and recent transactions. So this is what you see when you first log in, a real working application running entirely on Google's infrastructure without any hosting costs at all. Now I will click on the POS button to demonstrate how to make a sale. Products load from the database in a grid layout. Each product card shows the name, selling price, and current stock level. All this data comes from our Google Sheet in real time. I can click on any product card to add it to the shopping cart. Let me add sugar first and then bar soap. Both items appear on the right side with their prices listed. The total updates automatically as I add items. The cart clearly shows what the customer is buying and the total amount due. Now I click the checkout button and a modal appears with payment options. For cash payments, I enter the amount given and the change is calculated automatically. For mobile money, I click the M-Pesa option, which prompts the customer to enter their PIN on their phone. For credit sales, the customer must be registered first and I can select their name and add notes about the purchase. The system also supports split payments where a customer can pay using multiple methods. For example, they might pay part in cash and the rest on credit. I can record how much goes to each method. For this demonstration, I will just go with cash and click the complete sale button. The payment is processed and the receipt shows the sale was successful. Sugar and bar soap, totaling 360. I close the receipt and now let us look at the product section. Here we have a table showing all products with their names, categories, prices, and stock levels. Clicking the edit button on any product opens a modal where I can update the name, adjust the price, change the category, or update the stock quantity. I close the edit modal and click on categories in the sidebar. Categories organize products into groups like food and beverages, making it easier to find related items. The Add Category button opens a form where I can name and save a new category. The entire system runs on Google's powerful servers completely free of charge. There are no hosting costs, no servers to manage, and no maintenance needed. Google Drive stores all your data securely with automatic backups. Everything runs reliably day after day without any effort on your part. The system includes many other useful features. Stock movement shows how products have been moving over time. I can see which products sell fast and which need restock. Sales history displays all past transactions with timestamps showing exactly when each sale was made. Debt tracking records who owes money and how much. I can record payments as customers settle their balances and the system keeps a running total. The customers section stores each person's name, phone number, and balance. I can quickly look up any customer's purchase history. Units lets me set up measurement units like kilograms, liters, or pieces. Activity logs track who logged in and what changes they made, providing accountability and security. The system also supports different user permission levels. Cashiers can process sales but cannot change prices or settings. Managers have full control over products, categories, and configurations. Viewers can only see reports without making changes. Each user gets their own login credentials. The system works on any device with internet access. Switching to mobile view shows how the interface adapts to smaller screens. The sidebar collapses and the buttons become larger for touch input. The navigation is redesigned for easy thumb access while all core features remain accessible. Switching back to desktop view restores the full layout with the sidebar expanded and all navigation options visible. That is the finished system with all features demonstrated. Now let me show you how to build something like. Alright, so in part 1, we saw the final product, a fully working POS system. Now in this video, I'm going to show you the code that powers it. How a professional developer structures and organizes their code base. By the end of this video, you'll understand how everything fits together. So first, this is the project. I'm going to open it in VS Code. If you don't have VS Code, go to code.visualstudio.com. It's free and it's the best editor out there. Now look at this. Before we even look at a single line of code, look at how this project is organized. We've got a src folder, that's all the source code. An audit folder. And at the root level, all these markdown files, architecture docs, workflow docs, migration plans. This is the difference between a professional code base and a quick script. When you open this, you instantly know what's going on without reading any code. Inside src, 3 folders, core, modules, UI. That's it. 3 layers. Think of it like a restaurant. Core is the kitchen infrastructure, the stoves, the plumbing. Modules are the recipes. UI is the dining area, where customers interact. Now, this structure was planned on purpose. I'll actually do a whole video on how to plan a code base before you build. But for now, let's look at what we have. Now here's the thing about appscript. Normally you write code in Google's online editor. It works, but it's not great for serious development. That's where CLASP comes in. CLASP stands for Command Line AppScript Projects. It lets you write AppScript code in VS Code and push it to Google. First, install it. Open your terminal, run npm install g at Google to CLASP. That's it. Then run CLASP login. This opens your browser, you log into your Google account and grant permission. Then you're connected. Now in my project, I have a .clasp.json file. This tells CLASP which Google AppScript project to sync with. It just has a script ID and says the root dir is src. That's all. Now when I run CLASP pull, it downloads all the code from Google servers into my local src folder. And when I make changes, CLASP push sends them back up. This is huge, because now I can use VS Code, Git, AI assistants, all the modern tools. But I'm still deploying to Google's infrastructure for free. Watch, I'll make a small change and CLASP push. Done. It's live. That's the workflow professional AppScript developers use. Next up, GitHub. This is where we back up our code and track changes. It's free and it's industry standard. In your project, run git init to initialize a git repository. I already have a .gitignore. This tells git what not to track. Node modules, environment files, VS Code settings. You don't want to push those. Then git add stages everything, and git commit env initial commit saves a snapshot. Create a repo on GitHub, copy the remote URL, run git remote at origin URL, then git push origin main. Your code is now backed up and version controlled. Now you have the trifecta, VS Code to write code, CLASP to deploy to Google, and GitHub to back it up. Now this is the game changer. I use an AI coding assistant called Freebuff, and I'm going to show you how it connects to this project. When I open Freebuff from inside my project folder, it reads the entire code base. It understands the architecture, the naming conventions, the patterns I use. I'll put my referral link in the description. If you sign up through it, you get bonus credits and it supports this channel. It's completely currently free to use, no credit card needed. Watch this. I'll ask it, explain the database layer. And it tells me exactly how it works, pointing to the right files. This is what I mean by agent-ready code base. The AI can understand your project instantly because it's well structured. Every file, every folder, every naming convention is designed so that both humans and AI can read it easily. Let's step back and look at the big picture. Here's everything that powers this POS system, and it's all completely free. We've got VS Code, our editor. That's free. Google AppScript, our backend. Also free, and it runs on Google servers. Google Sheets, our database. Completely free. CLASP connects VS Code to Google. Free and open source. GitHub, version control and backup. Free as well. Freebuff AI assistance. Free to start. That's a production-ready stack for $0. You can run a real business on this. Here's how it flows. The user interacts with the UI are HTML pages rendered by Google. The UI calls the backend through google.script.run. The backend talks to Google Sheets as its database. And the router in the middle directs traffic, checks authentication, and calls the right services. Simple. Clean. Effective. Now let's talk about AppScript itself. Because if you're used to Node.js or PHP, this is a little different. Every AppScript web app starts with doGet. This is the entry point, like index.php or apt-get/ginexpress. When someone visits your web app, doGet runs and returns an HTML page. We use HTML service.createTemplate from file to load HTML files. Notice the equals syntax, that's appscript's template engine. It lets you inject server-side content into your HTML. I have a helper function called include. It just loads an HTML file and returns its content. This is how we break our UI into multiple files instead of one massive HTML page. In index.html, you can see the load chain. We load state first, then API, then router, then components, then services, then pages, then boot. Order matters, you can't use a service before it's loaded. And on the front end, google.script.run is how we call backend functions. It's like fetch or Axios, but built into appscript. The key difference from normal JavaScript, communication is asynchronous and data goes through JSON serialization. That's why all my backend responses use JSON.stringify to make sure complex objects transfer cleanly. Alright, now we get to the main event. Let me walk you through the entire code base. The core folder is the engine room. Everything the system needs to function. This is router.js, the traffic controller. Over 40 different actions are handled here. When the front end says get_products or create_sale or verify_session, the router directs it to the right service. Here's allservice.js. This handles login, it checks the email and password, looks up the user in the users table, and if valid, creates a session. The session is managed through sessionmanager.js. It uses Google Script Cache, think of it like a temporary storage locker. The user gets a token, and that token is stored in the cache for 6 hours. Every request checks this token. And authmiddleware.js has two critical functions. RequireAuth checks that you're logged in. And RequireRole checks that you have permission for specific actions. Only admins can delete products, for example. Now this is the part I'm most proud of. The database layer. Let me show you how it works. This is db.js. It's a mini database ORM, object relational mapping, built on top of Google Sheets. I have a DB class and a table class. The table class has methods like findAll, insert, update, delete, and where. This wraps the raw spreadsheet app API into something clean and predictable. findAll reads all rows, maps them with the header names as keys, and returns an array of objects. Beautiful. Then we have the schema layer. Each table gets its own schema file. Products.schema.js just returns an object with the table name and the column names. Simple. Declarative. And schema registry.js, this is the central registry. It collects all schemas into one array. There are 16 tables in this system. Now the migration system. This is the magic that makes it work. MigrationRunner.js goes through every schema in the registry. For each one, it checks if the sheet exists in Google Sheets. If not, it creates it. It sets the headers. Then it logs the migration. MigrationTracker.js is simple, it just records which migrations have run in a special migrations table. So we never run the same migration twice. And MigrationHelpers.js, this is where the real work happens. Create sheet if not exists, creates a sheet if it's missing. Set sheet headers, writes the column headers. But here's the clever part, if the sheet already exists and you add a new column to your schema, it only adds the missing columns. It never overwrites existing data. And relations.js, this defines relationships between tables. Which tables have many of another, which tables belong to which. Like sales has many sale_items, products belongs to categories. Finally, seeders, pre-populated data. When you first run the system, it seeds default users, categories, and roles so you're not staring at an empty database. And in code.js, there's a function called setupSystem. It runs migrations, then runs seeders. One function call sets up the entire database. So this is the key insight, you never need to touch Google Sheets. You just define a schema, run migrations, and the system builds the database for you. This is how you create tables without opening the Sheets UI. Now the modules folder. Each business domain gets its own folder. Take products. We've got productservice.js handles CRUD operations. Productvalidator.js validates data before saving. And stockservice.js manages inventory. Each service follows the same pattern. Require auth to check permissions. Validate input. Insert update delete through the database layer. Log the activity. Return a response. Consistent. Predictable. We've got modules for products, sales, categories, stock movements, units, customers, debts, users, activity logging, settings, communication, email or SMS, and M-Pesa payments. If I need to add a new feature, say, suppliers, I just create a new folder in modules, add a service and validator, register a schema, and I'm done. Everything else is handled by the structure automatically. And finally, the UI layer. We've got 13 pages, login, dashboard, POS, products, categories, units, sales, stock movements, settings, customers, debts, users, and activity logs. 12 front-end services, cart management, checkout flow, pricing, search, toast notifications, modals, tables, printing, receipts, barcode scanning, UI utilities, and edit modals. Reusable components, sidebar, top bar, modal, table. And a centralized state, a cart state.html. This is the single source of truth for cart data. Every component reads from state and writes through services. The load chain in index.html is critical. We load in order, state API router component services pages boot. Each layer depends on the one before it. This modular structure means I can change any page without breaking the rest. I can swap out the table service without touching the products page. That's the power of good architecture. Let me quickly show you the security model because it's built into every layer. Require auth checks if the session token is valid. If not, access denied. Require role checks if the user has the right role, admin, cashier, etc. The _sanitize method strips password _hash from user data before sending it to the front end. Passwords never leave the server. Activity logger records every action, who did what, when, and on which entity. This is your audit trail. And on the front end, permission service hides buttons and sidebar items that the user doesn't have access to. If you're a cashier, you don't see the delete product button. Security isn't an afterthought, it's baked into every service, every module, every page. So let me recap what we covered. We looked at the VS Code setup and project structure. We saw how Clasp connects local code to Google. How GitHub backs it up. How Freebuff makes AI-assisted development possible. Then we walked through the entire code base, the core infrastructure layer, the database layer with schema-driven migrations, that's my favorite part, the business modules that keep each domain clean and separate, and the UI layer that brings it all together. And we saw how security is built in at every level. Now before we start actually building one of these from scratch, and we will, there's one more video I want to make. It's called How to Plan a Professional Code Base Before Writing a Single Line of Code. We'll go through architecture documents, implementation plans, security planning, the whole blueprint process. Because you don't build a house without a blueprint. So in the next video, we plan. Then after that, we build. If you want to follow along in the build video, go ahead and keep VS Code installed, we'll start from scratch together. My referral link for Freebuff is in the description, it's free and it gives you both bonus credits to start using AI in your projects. If this video helped you, hit like and subscribe. And I'll see you in the next one.